it would not be the equal sign for one. It would be just greater than that.
If it's still inconclusive, I can't say that it converges, can I? Therefore, I'm just going to leave it between the two. They use a trick that I'm not going to use with you, and I'm just going to say that if you get inconclusive, then that means you can't prove that it converges at the end point. Therefore, you're left with it going right up to the end point. Okay? And that'll work for us at Cal 3. What they did is that they did some manipulating with the series and noticed and made it an alternating harmonic series. And the alternating harmonic series converges. But I'm going to say, if you get to inconclusive, it's okay for you to tell me I'm not going to use one in my interval. What I want you to notice is, how many points are there between -1 and 1? An infinite number, right? So we've got an infinite number of points that will work, right? And then we've got 2 that don't work. So we could have stopped by saying a interval of convergence would be the original one I wrote up there. Couldn't we? Do you follow? And not even bother to test the endpoints. And if an endpoint becomes critical, then we could move the series over, right? Make sense to you? Okay? So all I'm saying is, unless you can prove that it converges, it's okay to tell me that the ratio test was inconclusive, and I've told you to stop when the ratio test is inconclusive. Okay? Okay. This is example 3B. I think I'm going to do 3C because I'm running out of time. This is 495. Golly. So. I don't know. I'm gonna look. Yeah, 595.
You said while you were explaining that problem that the test starts tomorrow, but the syllabus shows it starting today. Is it today or tomorrow that it starts?
It starts today. Yeah. It starts today. It ends tomorrow. Okay. So this is 5. It's too low.
Do you do the ratio test on all the power series that we're doing?
Yeah. Yeah. We're going to use the ratio test every time. The ratio test or the root test. I don't know where Dr. Thomas is. I'm not gonna call the name of anybody else that's absent. All I'm gonna say, Travis, is if you run into anybody else that's absent, will you tell them that I said you can't make a good grade in this class unless you come to class? Would you deliver that message for me?
Yeah, I keep going with that.
That's A sub n, right? That's the nth term, A sub n? Right there?
It's example 3C. So.
Say what? No. Say what now?
It's example 3C that you're working
This
with.
is example 3C. Okay? So I want to use the ratio test, and I want to consider the absolute value of A sub n plus 1 over A sub n. And that's going to be x to the n plus 1 over n plus 1 factorial times n factorial over x to the n. And I'm building what I'm going to take the limit of, right? Everybody agree? So now I have, that's n plus 1, and that's x. And that's equal to x over n plus 1. Am I right? And the limit as n approaches infinity of x over n plus 1 is equal to x over infinity. Is that true? Which is equal to 0 for all values of x. Is that right? So 0 is less than 1 for all x. So the IOC is what? What values of x will allow that to converge?
All values.
The integral of convergence is all values for x. That's one way to write it. Or doesn't that say all values of x? Or doesn't that say all values of x? Pick any one you like to include the first one. I bet you course compasses don't want to see that. They're a little bit more uptight now. So here's one that Freelo says use any old value you want for x, it doesn't matter. Okay? Alright, one more. At least one more, maybe two more. This is 3D. And it is this is gold star material, y'all. And that is with me sitting down over here, I'm sitting over here because I don't have anything to write, because I know the interval of convergence right this minute. Anybody want to tell me anything about that? William wrote down the tests in order for convergence. Huh? What's test 0, William?
This is the limit equals 0.
You want to answer that question?
I guess it would probably be more than 1.
The answer is it's not 0, right?
Yeah.
If test 0 says you take the limit of the nth term. If it's equal to 0, that means what, William?
If it's equal to 0, then keep going.
It might converge, yeah, you keep going, unless it's an alternating series. So, but if it's not equal to 0, you stop right there and you go, eh. What's the limit of that as n approaches infinity? Don't I have infinity factorial over x to the infinity? Does everybody agree? Doesn't that look like infinity to you? So, I'm going to say it diverges. Because the limit as n approaches infinity of a sub n is not equal to 0. So, what I would like to say is that the IOC, if it converges, is the null set. But just common sense tells me that, wait a minute. Yeah, just common sense tells me that if x is equal to 0, then am I not back to the sum of 0 plus 0 plus 0 plus 0, which converges to 0? Is that right? So technically, the only number that makes it converge is 0, which means it's a trivial solution. And what a researcher would tell someone about that series is that's no good, because you can't make it converge anywhere but 0. Everybody get it? Okay? Do you know what I'm talking about? Am I cutting you a break there?
Is that for all? Is that for all of them?
Yeah.
Okay.
What I'm saying is, like, in this problem, didn't we get to here in a hurry? And didn't we spend more time checking the endpoints than we did getting to where my finger is? And my tests are long enough, would you agree? So I'll cut down what you have to do on the test. Everybody follow? And let's be clear, I'm only leaving out 2 possible points out of an infinite number of points. And if either of those mattered in what we were doing, then I'd test that endpoint. But until it matters, I'm not going to test it. And that's the way I've been doing these for a long time, and it works pretty good, huh? Everybody follow? So that cuts it down some of the work for you. Okay. I got to show you a couple of other things. I'm going to start one. And that is, if I know that do you agree that's the series? That's the series written 2 different ways. Do you agree? Then I think somebody want to read off to me what it is with the top line above?
Is that the
Yep.
same?
0,
0,
1, 2x, 3x squared.
Now, for all you brave hearts, somebody want to tell me what that is?
From x
Did I miss something, or isn't that the way we take derivatives of x to a power?
Right.
Everybody agree?
what wouldn't n minus 1 down low have to be? We're starting at 1, right?
Ah. Aha. Notice the change in the index. Because if I started in at 0, I'd get away with it here, wouldn't I? Because I'd have 0 times 1 over x. So I got away with it. But a infinite series, a power series is made up of positive powers of x, huh? And if n is equal to 0, then I wouldn't get a positive power of that. But I got away with it. I could get away with it. If you put a 0 there, I couldn't mark it wrong. Because what you'd get is 0 times 1 over x, and that's 0, huh? But you do move it up 1. Okay? Everybody all right with that? I'll do this one. I think that's 2 plus 6x plus, that was 3, that was 4x to the third, so that's 12x squared. Is that right? And that is, now I have n times n minus 1 times x to the n minus 2. Look, I multiplied by the exponent, and I subtracted 1 from the exponent. Huh? And I'm going to start that one at 2. Do you remember if I have an infinite series, I can just ignore a few terms or ignore a whole bunch of terms, even if I could ignore 100 terms if I wanted to, right? Because it just matters what goes on out at the end. Okay? All right, time to stop. See you Wednesday.